Okay, here's a preview video, or like a review, a preview, or a review of simplifying Simplifying is kind of like another way of saying reducing, right? Simplifying a ratio. A ratio. Another kind of fancy way that they'll say ratio, or you'll see the word ratio kind of as one of the root words, is you'll hear the word a rational expression. But do you see how right here it says ratio, kind of like in the word rational or ratio? Anytime you hear anything ratio or rational, a ratio is kind of just fancy, a little bit of fancy way of saying a fraction. We can write a ratio as a fraction. Okay, so here we go. So with these ratios, these trig ratios that you're finding, right? Because you have the triangles, and you have to find side, right? You got like a 3, 4, 5 triangle like this, 3, 4, 5, and you have to find, you know, the ratios. Okay, that's already explained in the first video. But what I wanted to explain to you, what I wanted to focus today about simplifying. So we're simply going to do an exercise on some of these ratios. And what you're going to see now is some of these ratios will have like the square root, like this radical, right? So let's say we're just gonna focus down on the simplifying part. So here's an example. Number 1. Let's say if I have the square root of 5 over 2. There's no need to simplify this. When you have the ratio on the top, which is the numerator, we know this is the numerator. We know that's the denominator. But when the when this square root is in the top in the numerator, you're okay. You always check the whole numbers though. This is the only whole number here. If it doesn't have a whole number, we know there's like a 1 right there, but we don't need to write it. We always check to see if you can always reduce this, but if you get a ratio or something like the square root of 5 over 2, there's nothing to do. It'll stay like that. It's okay. It's okay when you have the radical in the top in the numerator. You're fine. You don't have to fix anything. But that's not the problems I'm talking about. Let me do another one. What if I have 8 root 2 over say something like 16. Okay, again, we are okay. This is okay. This is okay to have the square root on the top in the numerator. It's okay to be there. I don't have to worry about that. But you always check. You want to always check to see if you can reduce these whole numbers over here. You never reduce a number inside the radical, inside the square root with the whole number. Just whole numbers with whole numbers. And 8 can go into 16. 8 goes into 8 once. Eight goes into itself once, and 8 goes into 16 2 times. So again, if there's a 1, remember you don't have to write it. So this will be the square root of 2 over 2. Okay, one more like this, one of these easy ones, and then we'll get to the ones that I want to build up to. Again, what if I have something like 12 root 3 over 10, something like this. Again, you gotta really double check all this. But when you have a radical on the top, we're okay with it. You don't have to worry too much. when the radicals in the bottom are the ones we're going to look at next. Those are the ones we have to fix. But right now, when it's in the numerator, it's okay. It's okay for this to be here. Okay, that's fine. But again, you always check to reduce and see if you can reduce the whole numbers. Yes, we can reduce a 12 and a 10 by 2, right? Or at least even numbers. So if I reduce this by 2 and I reduce this by 2, that'll be 6 root 3 over 5, right? Take half of 12 is 6. Take half of 10 is 5, right? Okay. Okay, those are not the problems I'm worried about, but I did want to make sure that you understand that when the radical is in the numerator, it's okay. But again, always check to see if you can reduce the whole numbers. All right, now the problem is the ones you're going to encounter now in some of these. And again, this is just fancy terminology. They call this rationalizing the denominator. Rationalize the denominator. Okay, don't be too worried about all this fancy, this fancy math talk. Okay, but what I want you to make sure that you're aware of, let me do number 1 for this one, is something like this. 5 over root 2. Okay, here's the problem. You can't have, this is a big no-no. This is why it says to rationalize the denominator, because the denominator cannot, you cannot have a square root, any kind of radical here in the denominators. You cannot leave it like this. We're gonna fix it, and this fixing part and this rewriting part, that's called this. It's called this rationalizing the denominator business. But for you and I, just to keep it simple, just remember, you cannot have a radical in the denominator. Again, let's go back over here. Remember, when it's in the numerator, you're fine. You don't have to rationalize it. But when it's down here like this, yeah, that's what we're going to learn and we're going to fix. So we got to fix this. We cannot leave it like this, okay? So this is how you fix it. This is how you rationalize the denominator. Okay, so I'm going to start with the 5 and the square root of 2. And what you're going to pretty much do is, right, we want to make this a whole number. We don't want a square root here. Well, we've kind of done this before, right? If this is a square root of 2, would you agree that if I multiply another square root of 2, remember if I have 2 of the same kind, it becomes a whole, the whole number, right? And if I if I multiply the denominator by this, I also multiply the numerator by this, okay? And that's just the way you're going to do it. Remember, this has a value of 1. Anything over itself is 1. So you're kind of multiplying it by 1. It just doesn't look like that. It looks like a different number. But it's fine. Just remember that your objective is to fix this. If this was a 3 right here, then you'd be multiplying by a radical 3, and then on the top by a radical 3, right? Whatever you do to the numerator, whatever you multiply to the numerator, you multiply to the denominator. So pretty much whatever is here, that's what you're going to be multiplying, right? And like I said, what happens when you have a square root of 2 times another square root of 2? That becomes a whole number 2, right? That I have 2 of them, right? Remember when you have 2 of the same kind, they come out as a whole? Yeah, under the radical. And now what's left over here? Well, just 5 root 2. And see, now you're okay. Now this is okay. Now this is an acceptable form. This answer and this answer, it's actually the same answer. I know it doesn't look like it, but if you actually do this in the computer and you look at the decimal equivalent value of this, and then you do this on, did I say computer or calculator? And if you do this on the calculator, and then you'll see it's actually the same. It's the same value. It just looks different, okay? But we just cannot leave an answer in math. We cannot leave it with a radical in the denominator. So we have to rationalize it, and that's this business. So this is the correct form of this. These answers are the same, okay? Let's do another one. Number 2. So let's say if I have 7 over root 3. You see? This is when you have a problem. You cannot have a radical in the denominator. So you have to fix it. Oops, fix. We have to fix that. Just like over here, we had to fix it. We have to fix it. I'm saying fix, but technically you're rationalizing the denominator. Okay, because we cannot have that there. Okay, so what do? I copy this again, 7 over root 3. And pretty much, whatever this radical is, whatever this root down here is, you're going to multiply by that, right? In this case, you're going to multiply by another root 3, right? Because I need 2 of those to make a whole number. It's going to make it a whole number. And whatever you multiply here, you multiply here. And what's going to be left? Well, here you're going to have, remember you all have 2 of them. Why is this running out of ink? Okay, throw it out. Throw it out. See, these, when you put them together, there's 2 of them, so it becomes the whole number 3. And then this, when you multiply 7 times root 3, it's just, remember the 7 is a whole number, that stays outside, and the 3 is a radical, well, it stays radical 3. Okay, let me do 2 more real fast. These will have a little twist to them. Here's number 3. What if I have 8, here's number 3, right? What if I have 8 over root 2? And then I'm going to tell you, well, cannot have a radical in the denominator. I have to fix this. I cannot leave an answer like this. Okay, so you're going to say, I got this. Then I have to do what? 8 over root 2. I have to multiply by what? Another root 2. I should have picked another number. Darn. I should have made it some other different number. Anyways. Yeah, you multiply by 2, you multiply by root 2. Okay. And it looks like it's the same like before, right? And this will make, again, what's the whole point of doing this? Because I'm going to make this a whole number 2. Now my denominator is a whole number 2, right? The square root of 2 times the square root of 2 is 2. And 8 times the square root of 2 is 8 root 2, yeah? And then, we're all happy. Okay, I got it. But see, stop. This is not your final answer. Why? Because, and I should have done this in number 1 and number 2, but before you think you finish and this is your final answer, remember, always check these whole numbers that are left over to see if you can reduce. I already knew the first 2. I already knew these when I did this over here. Oops, sorry, go back to number 1. I already knew the 5 and the 2 couldn't reduce, so I didn't do it, but I should have mentioned it. I already knew the 7 and the 3 couldn't reduce, but I should have mentioned it. You always look to see that. My bad, guys. Okay, so here, up. Here, the 4 and the 2 will the 8 and the 2 is going to reduce. 8 divided by 2 is actually 4, right? 4. So this will be, right? 8 divided by 2 is 4. 4 root 2 is your answer. You still got the root 2. Okay, let me do one more. Number 4. So what if I have root 10? Oh my God, why am I making so many mistakes? What if I have 6 over root 10? I'm sorry, guys. Hey, I'm human, huh? Incredible. All right. Can I have an answer and leave my final answer like this? No. Remember, you cannot have a radical in the denominator. You have to fix this. We have to rationalize this denominator. Okay? So, what have I been talking about? Well, let me copy it again. you're always going to multiply by what? Another one of these, right? Whatever it is. Well, in this case, it's a root 10. So multiply the top by a root 10. I'm sorry, multiply the bottom by a root 10 and the top by the root 10. I'm even saying things backwards. Wow. Something's happening with me. And what's left here? Well, remember why you're doing this. The square root of 10 times the square root of 10 is just going to give you 10 in the denominator. We want a whole number. We don't. This is the way we're fixing this so that we don't have a radical anymore. Square root of 10 times another square root of 10, 10. And then now 6 times the square root of 10 is just 6 root 10. Yes? Yeah. And again, before you think this is the final answer or you believe it's your final answer, always check the whole numbers here. See if these can reduce. Never reduce like this 10 with another or any number inside a radical. Okay, those don't reduce. Only the whole numbers, okay? So yes, 6 and 10 can reduce by 2, right? At least by 2. They're both even numbers. So divide by 2, divide by 2. So the correct and final answer for this would be 3 root 10, right? And divided by 2 is 3, and divide the 10 by 2 is 5. And this would be the, see, so some of you are going to do some of your work here for the problems that we're doing, and you're going to get this, or maybe you'll get it to this, which is good, but then when you check your answer, it says this, and then that's why I want you to know why you're getting this, and the answer might say something like this. Always check to reduce. And again, you're gonna run into something like this. But again, going back to the beginning, remember, if the radical is in the numerator, you're fine. It's okay in the numerator, but again, you always check to reduce. All right. That's it. The next video will explain problems on the assignment. Thank you.